Hello, everybody. Good morning. My name is Torabi. I work in the water, energy, and environmental engineering research unit. Currently, I am a leader of hydrosystem engineering and management research group in this unit. So I was asked to talk about water resources, monitoring, and digitalization. I don't know how it's along with this conference and seminar, but I will try to give some background information to you regarding to the water resource in global point of view. Then my colleague, Dr. Pekarosi, gives some more detail regarding to Finland and some key question about the research in Finland. So I will talk about a little about importance of the water, water demand, environmental problem. Then I will switch on the environmental monitoring that may be some relevant to this seminar today. And finally, I'll give you some example from the remote sensing application in the water resources as our job in our unit. So everybody knows that water is most important element in the world. It has a economic value, and environmental value, social value, and every organism, individual, and ecosystem are dependent on the water. So if we have a poor water management, it leads to diseases and even environmental disaster. It is unique resource. There is no substitute and limited resources in the world. As you know, the world population increasing about 18 million per year. It means increase to the water demand about 64 billion cubic meter per year. And it's equal with the Rhine River in Germany. You know the Rhine. Annual Rhine flow to the North Sea is equal to water demand in the world every year. And huge amount of fresh water we need for the newborn people in the world. So based on the water stress index in the world, if a country has more than 1,700 cubic meter per capita per year, this country in sufficient amount of water, like Finland. But if the amount is less than 1,700, the country is under stress of the water. If it is less than 1,000, it is water scarcity, and less than 500 leads to absolute scarcity in the world. So, in 2008, 1 billion people in the world affected by water stress. And it predicted in 2030, over 3.5 billion people are under water stress in the world. So it is important to manage water resources. As I told you, world population increasing during last 300 years from 0.8 billion to 9 billion. And it leads to increasing the demand in agriculture, industrial, municipal, and other. As you see, the water consumption from 0.5 cubic kilometer increased to about 4,000 cubic kilometer. It means 8,000 times increasing in the water demand. And it is during 300 years. If you want to have imagination about this amount of the water, I change it to the water bottle. We need 4 times 10 power 15 water bottle for the world population. It is huge amount of the water that we need. So what we can do, because we need water for the people, and we need to modify the river. And this modification of the river makes some problem. Currently, 58% of the world river are regulated by dams and hydropower. And in the second half of last century, every day we have 2 dams constructed in the world. As a result, the amount of inflow to the fresh water is decreased. So we have more pressure in the aquatic ecosystem, like wetland, like lake, and etc. So it increased a lot of environmental problem in the world, like disappearing the lake, Aral Sea in Central Asia, Chad Lake in Africa, Urumia Lake in Middle East, are a sample of this appear in the lake, and there is a lot of health consequence regarding to this appearing. We have drying the wetland, dust storm. You know, when the lake is drying, when we have wind condition, the storms coming in the city, like this photo in Ahvaz city in Iran. And then we have degrading the water quality and eutrophication, major problem in Baltic Sea. You know, the water could be affected on different climate and make problem for the. But how about the solution? One solution could be, we call it environmental fellow. We allocate some fellow to release to mitigate the negative consequence of dam construction. It's the concept of environmental fellow. But if we want to solve the problem and we want to do good management for the water, we need to know how much water available in the world. The first question, or the philosophy behind of the monitoring, is that how much water we have already in the world. So answer this question could be regarding to how much water is the even single soil profile, or in a biotic component, or in the country scale, watershed scale, or in the global scale. And we have to know how much is rainfall, how much is the water in the river, how much groundwater, how much evaporation and evapotranspiration. All component in the water cycle, we have to know and understand what is that and how much is that. So in this purpose, we need to measure how much inflow come to the system and how much outflow from the system. The best way to do is that monitoring and digitalization. So why we need monitoring? To collect the data. To collect data to design new structure. If we want to design a new structure, we need to have a data to operate the structure, to predict what's happened in the future, to know what's happened, to be sure everything is fine, the water in the healthy condition, to decide for future, and to confirm our hypothesis about the water resources. All of these need the monitoring and measuring the flow and water data. So we measure the data and we measure water in the quality and quantity in different time scale, from hourly to annually, as I mentioned here. But we have two different ways for monitoring the water system or environmental system. One is traditional way that I mentioned here, and another one is the modern one, could somehow related to digitalization and the automation in the system. But what's happened in the traditional way, the most measurements are in analog system and person-based. When it is person-based, it is mistake coming in the measurement. As you see in the figure, these guys want to read the water level in the river. I'm sure there is a lot of mistake. And the climate affected on the measurement. Just thinking in the cold climate like here in Finland, we are going to measure something. It is difficult to go to the field and measure. So, and the other problem is that when we are in the traditional way, it is a slow process. And also delay to detect problem. If there is some problem happen, it takes time to detect it. But in the modern way, it is high technology based. And there is minimize the human error. We have better data for design structure. We can improve our efficiency of hydraulic structure. We have a real-time monitoring. If something's happened in the system, we could immediately recognize it and make reaction about the problem. So, digitalization and remote sensing could some part of this modern technology. So, let's talk about a little application of remote sensing as the last slide. What is the remote sensing? Any of you, do you know the idea? Remote sensing is that we measure something without physical touch, like our eyes. it is too good sensor as a remote sensing, because without touching, we can measure everything. So from 1970, when the first Landsat launched to the sky by United States, they started to use remote sensing in the water resources. By using remote sensing in the water resource, we can estimate the water body area, as I mentioned here, prepare the land use, land cover change, as this map in Finland that we done in the project. We can calculate evaporation, evapotranspiration, soil moisture, snow cover, change in the groundwater, river flow measurement, and river morphology. Here is several examples from our work in University of Oulu. In this case, we calculate the land use in the one peatland area. Here we measure the river morphology, and here we look at the change in the water area in the lake in southern Iran called Bakhtigan. Thank you very much for hearing me.